Okay, so let me just kind of edit this a little bit, okay? Okay, officially now recorded, Nick. Okay, so let's go back. Nick, did you get offended? Do you want me to erase it and maybe put my name in there? And then I'll put foot, Nick's foot. How's that? Okay, so here's the math, okay? So yeah, this is what I want, okay? So what the theorem is telling you is that there are three functions, okay? There's g of x, there's h of x, and then there's another function f of x in between the two, okay? So this is h, and then the one in the middle is f. The theorem is in some ways kind of obvious when you look at the diagram. And what it's saying is that if the function f is in between g and h, like it tells you here, okay? It's between those two. And if the two outside functions, which is h and g, have the same limit, then what do you think the limit of f is going to be? Sorry? Excuse me? Well, I mean, the things are written there. So I'm asking you, what do you think this would be? Can you be a little bit more precise? L. Okay? Because f is in between two functions, and the two outside functions have the same value, as you can see, the same limit, then the one in the middle has got to have the same limit. It can't go anywhere else because it's been squeezed between the two. You guys got that? So it's kind of fairly intuitive. I mean, the proof is a little bit of work, but we don't want to worry about that, okay? What we want to do instead is actually use this result to do this limit. Okay, now this is a really important result.
Is that theta?
Yes, that's theta. So instead of x, I'm using theta. You don't need to write C picture, okay? I need to show you that. So what you want to do is write that limit, and then after that you'll have a picture. Right, you guys ready to look at the picture? Yes? Okay. So this will take a little time to get down, okay? So you need to get this down. Just give me a minute, okay? Okay, so what we want to do is we want to look at areas of three different things. So my first question to you is, do you all agree? First of all, does everybody see that the circle is a unit circle? In other words, the radius is 1. Okay? Does everybody agree that that height is equal to tangent theta? From SOHCAHTOA. Straight out from SOHCAHTOA. Emily? Yes? Everybody okay on that? Renee? All right. Does everybody agree with the area of the triangle being that one? Because what's the base of that triangle equal to? 1. Height is tangent theta. So the area is 1/2 base times height, which is 1/2 tangent theta. So everybody with me on this? Okay. Yes? All right.
You show that real quick. I'm having a hard time.
Okay. Visualizing it? Okay. So let me get a pen, different colored pen. So this is the triangle I'm looking at. That's the triangle I'm looking at. And this height is tangent theta from SOHCAHTOA. Do you want me to work that out, or are you okay on that? pull the triangle out like that. That's theta. This is 1. It's my AB. Okay, this is A, B, and C. If I call this H, then remember that tangent theta is opposite over adjacent. Right? That's opposite, that's adjacent. So then H equals tangent theta. Okay? Right. So that's that. Let me kind of erase this stuff here too. And this is the sector here. So you guys know what a sector is, right? You guys know what a sector is? It's a pizza slice. Yeah, it's a pizza slice. That's the sector. Okay? Everybody okay on that? Do you may use a different color maybe? Let's see if this color stands out better. Is that better? So that's the pizza slice. Anybody remember the formula for a sector of a circle? Anybody remember that formula? Area of a circle, sorry? Of a sector. Actually, the real formula that I taught you last year was this. 1/2 r squared theta, where r is the radius. Okay, that's the formula I taught you last year. And if r is equal to 1, then the area is straight out theta over 2. So everybody okay on that? Right? R is equal to 1, because it's a unit circle. Radius is 1. So 1/2 r squared theta means 1/2 times 1 times theta, which is theta over 2. Right? 1/2 theta is the same thing as theta over 2. Okay? So we got that. All right. Now let's go to the area of the other triangle, ABD. Okay? So to look for the area of the other triangle, I'm going to use this as the height and this as the base. Everybody see that? I'm going to use this as the base and this as the height. So area of triangle ABD, is going to be 1/2. What's the base equal to? 1